In the last section, we talked about a quadratic formula. So an alternative to completing the square is the quadratic formula, and you can use it to solve quadratic equations. But if you remember, it was kind of taking us by surprise when we got our answers, because once in a while, our answers would be nice, they'd be fractions or whole numbers, negative or positive. And then sometimes our answers would have square roots left in them, and they wouldn't be very pretty. And then other times, I think one problem we did, our answers were imaginary numbers. And then one time, the one other possibility is you could have one solution instead of two. And that was a weird one. I think that was when we did the quadratic formula, and it ended up that the thing inside the square root was 0. Anyway, so let's just, instead of it coming as a surprise, like, oh, I guess we have two solutions and they're really pretty. Or, oh, I think we only have one solution. Or, we have two solutions and they're ugly. This section kind of talks about how you can predict what kind of solutions you'll have. If you'll have one or two solutions, will they be nice solutions? Will they contain a square root? Will they have imaginary numbers? That kind of thing. So, the idea behind it is, if you think about, let's see, the quadratic formula, how does that guy look? If you remember, he's x equals, negative b plus or minus square root of b squared minus 4ac over 2a. And really what dictates how many and what type of solution or solutions you'll have is what happens inside the square root. So once you plug in your values of a, b, and c into there, it kind of depends. Like if that ends up being 0, like the one example we saw in the previous section, then you're only going to have one solution, and the square root just kind of disappears because the square root of 0 is 0. If what's inside the square root is positive, then you're taking a square root of a positive number, and that you're going to get real answers. And I guess it kind of depends if that number you end up with inside the square root actually has a square root, then it can escape the square root and your answers will be nice. But if it's a positive number and the number itself doesn't have a square root, your answer will end up with a square root in it. And then the last thing that can happen is that thing inside the root, the b squared minus 4ac, it could be a negative number, in which case you're taking the square root of a negative and your answers will be imaginary. So really, what's inside the square root of the quadratic formula, that's what's going to dictate what kind of solutions you'll get, or whether there's one or two. Are they nice? Are they terrible? Are they imaginary? So that thing inside the thing inside the root is so important that we give it a special name. Like it says here, that's called the discriminant of the quadratic equation ax squared plus bx plus c equals 0. So b squared minus 4ac, that's what we call the discriminant, and that's because that's what's inside the parentheses, and that's what's inside the square root, and that's what kind of dictates how many and what type of solution you'll have. So inside this box we have kind of a description of, depending on what happens with that value, the discriminant, all kinds of things can happen. So let's kind of read it over. So first thing that can happen is if that value of the discriminant, b squared minus 4ac, if it's equal to 0, which we saw one time in the previous section, there's only going to be one rational solution. And if you're wondering what the heck is rational, really rational just means, I guess there's no root left. Your answer won't contain a square root. It's just a nice fraction or a whole number, and it won't be imaginary. So just so you know what rational means. Okay, that's one thing that can happen. The second thing that can happen is if what's inside the square root is positive, or in other words greater than 0, there'll be two solutions. But there are two possibilities even within that. So if b squared minus 4ac, the discriminant, is positive or greater than 0, it could be that those solutions are rational, and that'll happen if that value of the discriminant, b squared minus 4ac, actually has a square root. Because if that thing actually has a square root, the square root will disappear and we'll be left with nice fraction or whole number answers. But on the other hand, the solutions will be irrational if b squared minus 4ac has no square root. So I guess you can imagine irrational is just the opposite of rational. That means there's still a square root, or it contains a square root. Anyway, so the homework, it does try to differentiate between those two things, rational and irrational. So we'll have to see. So probably this situation here where b squared minus 4ac is greater than 0 or positive, that's the most complicated probably situation to be in, because not only does that mean there are two solutions, but then you have to worry about, well, what kind of solutions are they? Are they rational or are they irrational? So we'll have to think about that in the examples that we'll see. And then the last possibility is that maybe the discriminant b squared minus 4ac is less than 0, which means it's negative, because anything less than 0 is a negative number. That would mean that there are two imaginary solutions. Because you can kind of picture, if the b squared minus 4ac is negative, that means what's inside the square root is negative. And of course that produces imaginary solutions. So in this section, we're not really interested in the actual solutions of these things. We're only interested in, okay, if we had the solutions, what type are they? Are they rational, irrational, imaginary? And then are there one or two of them? I guess that's what we're wondering. So that's what you have to declare here, kind of. We have to say, kind of answer this question, are the solution rational, irrational, or imaginary? So we'll have to decide which of those three it is. And then also, are there two solutions or just one? So that's what they mean by when they say the description there, example, determine what type of numbers the solutions are and the number of solutions. I guess the type is here, are they rational, irrational, or imaginary? And then the number of them, do they really just want to know, are there one or two of them? So let's see if we can figure this out. For example, the first part A. So really what they want you to do is just figure out, what is this discriminant here, b squared minus 4ac? And once we have that value, we'll just substitute the specific values of a, b, and c here. Like in this one, a is 1, b is -7, and c is 5. We'll substitute those in the discriminant, and we'll just see which category it fits under from the directions. Is it the first one where it's equal to 0? Is it the second one where it's greater than 0? Or is it the last one where it's negative? And then we'll just decide what happens from there. So let me see. I'll fill in our values of a, b, and c. So our b, it's b squared, our b was 1, minus 4 times a is 1, and c is 5. Wait, what? Oh, I put, b is -7, sorry. It's supposed to be -7 there, not 1. A is 1, not b. Alright, so it's b squared, that's -7 squared, which is positive 49. And then minus 4 times 1 is 4, times 5 is, excuse me, 20. 49 minus 20 is 29. Okay, so this is the value of the discriminant for this specific quadratic equation. And then now we just have to decide, going back to the directions here, which of these categories does it fall under? Is that thing equal to 0? Is it greater than 0? Or is it less than 0? Well, 29 is greater than 0, so we're in that second situation there. And the second situation says there are two solutions. So at least we know that. We know the number of solutions to this thing. And know that, just so you know, this value of 29, the discriminant, is not telling you anything about the solutions as far as, it's not like 29 is one of the solutions to this equation. 29 is just a value that'll let you know how many solutions and what type. We don't know anything else about the solutions. They have really nothing to do with 29. 29 won't be part of your solutions. It's just a value that'll tell you how many there are and then, what type they are. So we know that there are two solutions, but now we have to figure out, are they rational or irrational? Because that was the second part of step 2 here, or part 2. It says, okay, they are rational if the value b squared minus 4ac has a root. They are irrational if it doesn't. So we have to decide, now does 29 have a square root? No, it doesn't, right? 29 is not a number that has a square root. That means they're irrational. So that means, okay, we're done. Our solutions, the two solutions, are irrational. And if you were to actually use the quadratic formula on this equation, plug in a equals 1, b equals -7, c equals 5 into the quadratic formula, x equals -b plus or minus the square root of b squared, yada, 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 you'll see that you do get two solutions, and they'll be irrational, as in there will be a square root left inside. So let's try part B. And this is all they're asking for in this section. They don't want to know what the solutions are. They just want to know, am I going to have one or two solutions, and what type will they be? Will they be irrational? Will they be rational? Will they be imaginary? So part B, first, I kind of will try to do the same thing. We'll just say, I want to calculate what the discriminant is, b squared minus 4ac. And if you ever feel like, man, how am I going to memorize what the discriminant is? Just remember that it's the thing inside the square root of the quadratic formula. So it's not really anything new to memorize. It's just look at the quadratic formula and say, oh, the thing inside the square root. That's what I'm looking for. That's really it. So notice this problem, I think you're kind of missing a term because it's w squared plus 7 equals 0. But you kind of want it to look like ax squared, which we kind of have a squared term even though it's w, plus bx plus c. So I think we have the ax squared term here. A must be 1, and we have the constant term 7, but we're missing bx. So I think that would mean, like we said, a is 1, that's the coefficient of w squared. C is 7, because that's the constant term. But since there's no middle term, that must mean b is 0, since b doesn't exist. So let's substitute those values in. B squared, okay, b is 0, minus 4a is 1, c is 7. 0 squared is 0, minus 4 times 1 times 7 is 28. So we get negative 28. That's our discriminant. All right, if we look back up at this box up here, it says if the discriminant is negative, that's the third option right here. Because we don't have the first one. The first one says it's equal to 0, but our discriminant's not equal to 0. It's equal to negative 28. The second one says it's positive or greater than 0, but ours is not. The last one, it's negative or less than 0. That's where we are. And that just means right off the bat there are two imaginary solutions. That's really all we need. And again, that's because this number that we found is less than 0. So we're in that third category, sort of, up there in the box. So that would be your answer, just two imaginary solutions. And you don't really care what they are, you just care what type and how many. All right, we're doing pretty good. Let's try part C now. Part C looks a little nicer because it's already in the right form. It's ax squared plus bx plus c equals 0. So I can go ahead and identify a is 4, b is 8, and c is negative 5. All right, and then I'll just replace those in the discriminant b squared minus 4ac. b is 8, so I'll replace that guy, squared, minus 4 times a is 4, and c is negative 5. All right, let's see, 8 squared is 64. Then we have minus 4 times 4, that's negative 16. Negative 16 times negative 5 is positive 80, I believe. Sounds good. 64 and 80 is 44. There we go. So there's our discriminant. That's what we're looking at. And that's not really, they're not going to ask for that in the homework. They're not going to say, what is the discriminant? They're just going to want you to find it and determine on your own what type and how many solutions you'll have. So notice that that number is greater than 0, because that's kind of how we categorize it. The number you get, is it going to be equal to 0, greater than 0, or less than 0? So which category does it fall under? Well, it's not the first one, because it's not equal to 0. It is the second one, actually, because it's greater than 0. So we're back, kind of like in part A, we're back in the second category, where that means we have two solutions. But we have to determine, are they rational or irrational? So the second line up there says, they're going to be rational if your discriminant has a square root, but it's irrational if it doesn't have a square root. So looking at my number, I just have to determine, is my discriminant a number that has a square root? Of course it is, yeah, 144 has a square root, it's 12. So that must mean that the solutions are rational. The two solutions are rational. There we go. All right. We got it. I think we're doing pretty good. This is really all there is to it. You're just kind of looking at the discriminant and then saying, okay, which of those three categories in the box does it fall under? And then kind of follow the directions there. Let's try part D. We got some big numbers here. 25x squared minus 20x plus 4. So in that one, it's already in the right form also. It's ax squared plus bx plus c equals 0. So A is 25. B, don't forget you want to throw the negative in there as well. B isn't just 20, it's negative 20. And then C is 4, the constant term. So using those, let's calculate that discriminant, and then we'll see, is it equal to 0? Is it greater than 0? Is it less than 0? Let's see, B is negative 20, so we'll square that. Minus 4 times A is 25, and C is 4. Let's see, negative 20 squared, that's positive 400. And then here we have negative 4 times 25, that's negative 100. Negative 100 times 4 is negative 400. So it looks like this is the first time our discriminant will be 0. So there's our discriminant. Okay. There he is. Now we just have to see, of the three categories, what happens there? Is it equal to 0, greater than 0, less than 0? Of course that guy's equal to 0. 0 is 0. So this is the first time we've seen we're in that first category. And the first category says we have two rational solutions. Alright, and that's it. So you notice that if you fall into category 1 or 3, it's really simple because you know the answer right off the bat. That's one rational solution. Sorry about that. Yeah, you know right away, this one rational solution. If you fall into category 3, it's 2 imaginary. No need to do any more work. But if you fall into category 2, you know right away that you have 2 solutions. You just don't know if they're rational or irrational. So you have to do a little more thinking. Let's try part E. Alright, part E is not in the right form. It's supposed to be all the terms are on one side, and they're in descending order of powers. So first thing I got to do is work on this, because if I don't move everything to one side, I'm going to have the wrong values of A, B, and C. And if I have the wrong values of A, B, and C, then I'm going to have the wrong discriminant and come to the wrong conclusion here. Alright, now that I have it in descending order of powers, I think I can identify A, B, and C. So here A would be the coefficient of, x squared or y squared, whatever, 1. B is the coefficient of y, negative 4. And C is the constant term, 9/4. Alright, let's substitute those into the discriminant. B squared minus 4AC. B is negative 4 squared minus 4 times A is 1 and C is 9/4. There we go. So we got negative 4 squared, that's positive 16. We have negative 4 times 1, which is negative 4, times 9 over 4. You know what I better do? I'm going to put that 4 and the 1 over 1. And then think about multiplying those. Although I see that I can cancel these 4s, though even though they're kind of far apart, if you're multiplying 3 fractions together, you can cancel any numerator and any denominator you want. And once those are canceled, I'm really just left with negative 9, because the numerator is 1 times 1 times 9, which is 9. The denominator is 1 times 1 times 1. You end up with 16 minus 9, which is 7. There we go. There's our discriminant. And then to see which category it falls under, I just determined, is that number equal to 0, greater than 0, or less than 0? Of course, 7 is greater than 0, so we're in category 2. And we have to do a little more work. Even though category 2 does tell us there are 2 solutions, you have to think about what type. So we have to see, the question is, does that number that we found, 7, have a square root? If it does, that means they're rational solutions. If it doesn't, that means they're irrational. Well, 7 does not have a square root, so that means that the 2 solutions are irrational. Alright, good. So far, so good. Alright, we only have one more left, and I think we'll kind of get the hang of it at this point. So part F. It looks like I don't think I have everything in the right form, right? Because it's supposed to be of the form ax squared plus bx plus c equals 0. So first, I'm supposed to have everything on one side. I'm going to move this 48x over to the left. That way we'll have, and of course you want to write it in descending order of power, so I'll write the 5x squared first and then the 48x. So I think it looks like here we're missing c, because I see ax squared, that means a is 5. I see bx kind of, b must be negative 48. And then c, there is no c, that must mean it's 0. So those are our values of a, b, and c. I'm going to replace those in the discriminant. B squared minus 4ac. Alright, let's see. B squared excuse me, b is negative 48 squared minus 4 times a is 5 and c is 0. Let's see, what's negative 48 squared? Wow, 2,304. Oops. And it's positive because you're squaring a negative. Here you have 4 times 5 times 0, that's 0. So of course when you subtract those you get just the number 2,304. That's a huge number, but that doesn't really have too big a bearing on our answer. All we care about is that number equal to 0, greater than 0, or less than 0? Well, that guy is greater than 0, really, much greater than 0, which means we're in category 2 yet again. And the only thing we can say right now is that there are 2 solutions. But then the next thing would be, we ask, does that number that we found have a square root? And you could answer that question by using a calculator, but what's easier is just thinking, well, where did we even get 2,304? We got it from squaring 48, right? So since 2,304 is 48 squared, that means it must have a square root of 48. So I don't know about this one. I don't really need a calculator because I know this came from a square of a number, which means it has a square root. All right, that means our 2 solutions must be rational. There we go. We got the number and the type. All right, in this section it's pretty good, right? It's just kind of categorizing the types of solutions. It's really short. I don't think you'll have too hard a time with it. So it's kind of a nice break after the last couple sections, which have been kind of tough. So I hope everything made sense so far. We'll move on to the next section. Should be a little more interesting. Thanks. Bye.